Welcome to the lecture number 22. Today we are going to do this problem set number 5. Question number 12. It's a very lengthy sum actually. But still you will find if it comes in exam it carries 4 marks. So in this case you will find we need to prove quadrilateral PQRS as a rectangle. Here we are going to prove PQRS as a parallelogram first. So to prove it as a parallelogram, by distance formula we will find out length of PQ as well as SR. In the same manner we will find out length of PS and QR. If opposite sides will be congruent, then it will become parallel. Try to understand this first. So basically it is going to be a parallelogram only if we prove opposite sides are congruent. The next step is parallelogram becomes rectangle if its diagonals are congruent. So PR and QS, if we prove them as a congruent, then it becomes a rectangle. Now let's see here. You will find by distance formula. At once we will write the distance formula. No need to write the distance formula again and again. Only you have to apply it. You will get the marks, full marks you will get, don't worry for this. So distance formula I have mentioned it as x1 minus x to the whole square plus y1 minus y to the whole square. Even you can use it as y2 minus y1 the whole square, x2 minus x1 the whole square. That is one and the same. Values are not going to change at all. Now let's see here. PQ is equal. Now if I am going to find out the value of PQ, then you will find 2 minus of minus 1 is here. 2 minus of minus 1 the whole square. Y1 minus y2 1 minus 3 the whole square. Now 2 minus into minus is plus. 2 plus 1 is 3. 3 square is 9. Okay. In the same manner you will find 1 minus 3 is minus 2 and minus 2 square is 4. So you will find PQ is equal to root 13. Alright. So 3 square plus 4, that is 9 plus 4 is root 13. Likewise, now I am going to find out SR. Now minus 2 minus of minus 5, x1 minus x to the whole square, y1 minus y to the whole square, minus 5 minus of minus 3 the whole square. So that will give you minus 2 minus into minus is plus 5. In the same manner over here, minus 5 minus into minus will give you plus 3. So 5 minus 2 is 3, 3 square is 9 and minus 5 plus 3 is minus 2 the whole square. Of course it is going to be plus 9, so root 13. So this is how you will find we got SR as root 13 and PQ is also root 13. Now I am going to find out PS. Now to get PS, same formula, 2 minus of minus 2 the whole square is here. 2 minus of minus 2 the whole square plus y1 minus y2, that is 1 minus of minus 5 the whole square. 1 minus of minus 5 the whole square. So minus into minus will give us plus. So 4 square is 9 and 5 plus 1 6 square is 36. Try to understand this again. 16 plus 36 will give you 52 and square root of 52. Since you all know 52 is nothing but we can split it as 13 fourths are. 13 fourths are and square root of 4 is 2. So PS is 2 root 13. So this is how you will find PS is 2 root 13. Now let's find out other opposite side of PS which is QR. So QR is also equal to minus 1 minus of minus 5. Minus 1 minus of minus 5. You have to be very particular when next coordinate is minus. If you will not place bracket, you are going to go wrong. Now next to that is 3 minus of minus 3. So 3 minus of minus 3, that will give you 3 plus 3, that is 6 square. Plus 5 minus 1, plus 5 minus 1 is 4. So 4 square is 16. 16 plus 36, again we will be getting 52 and root of 52 is 2 root 13 because since you all know 52 we can split it as 13 fours. So this is how what happens now. PS we got it as 2 root 13 as well as QR also we got it as 2 root 13. So pair of opposite sides namely PS and QR, they are 2 root 13 each. In the same way, PQ and SR are root 13 each. So pair of opposite sides are congruent. If pair of opposite sides are congruent, then quadrilateral PQRS for time being becomes parallelogram. This is the basic property of parallelogram, that its opposite sides are congruent. Now, but what we have to prove? We have to prove that quadrilateral PQRS is a rectangle. Now to prove this as a rectangle, I am going to prove now diagonal PR and diagonal QS are congruent. So diagonal PR, same way, 2 minus of minus 5 the whole square, 1 minus of minus 3 the whole square. Again you have to be careful for placing brackets over. So you will be getting 2 plus 5 which is 7, 7 square is 49, 1 plus 3 that is 4, 4 square is 16. So 49 plus 16 will give us root 65. So you will get here PR as root 65. Now the next one is diagonal QS. Diagonal QS is also same way you will find over here. Minus 1, minus of minus 2, minus 1, minus of minus 2 the whole square, plus 3 minus of minus 5. Now 3 plus 5 is 8, 8 square is 64. 2 minus 1 is obviously 1, 1 square is 1. So diagonal QS is root 65. So what happens now? QS is root 65. PR is also root 65. That means diagonals of quadrilateral PQRS are congruent. As well as opposite sides PQ and SR are root 13 each. PS and QR are root 13 each. So this is how you will find if diagonals are congruent as well as opposite sides are also congruent, then quadrilateral PQRS becomes a rectangle. So this is how we prove this PQRS as a rectangle. Of course, you will find many calculations were there. Right? So 4 calculations are there. Please focus on this sum properly before I rub the board. Now I am going to do sum number 13. The sum number 13 is also problem set 5. Sum number 13 is also very lengthy. In that they have given us triangle. Okay, they have given us triangle. And vertices of triangle they have given us, and they ask us to find out the length of medians. They ask us to find out length of medians. So, if vertices are known, what is mean by median? Now, median you all know the definition that the segment drawn from the opposite vertex and joining the midpoint of the base. But midpoint of the base are not given. So, what is required is we must have to find out. We must have to find out the midpoint of the base also. So, our first job will be by midpoint formula. We will find out the midpoint of the base, and after that, we will be able to find out the length of the medians. Length of the medians we will find out by using distance formula. Now, please see here. The name of the triangle they have given it as ABC. So I am going to draw triangle ABC first. In examination, there is no need to draw. Here simply for sake of making your understanding this A, B, C. Now you will find they have given us AD is a median. CF is also median. and B is also made. Okay. Now coordinates are given. A is minus 1, 1. Coordinates for B are five minus 3. And coordinates of C are 3, comma. Okay, fine. So this is how minus 1, 1. Then you will find coordinates are 5 minus 3 and 3, 5. These are the coordinates. Now what I am going to do? First of all, I find out the coordinates of B. So let coordinates of B as x1, y1. So by midpoint formula. By midpoint formula. I already explained you that median is a segment joining or drawn from the opposite vertex to the midpoint of the base. So I am going to find out now coordinates of B. So you will find here coordinates of B, x1 is equal to 5 plus 3 upon 2. Sum of the x coordinates upon 2. So x1 is 8 upon 2, that is 4. Likewise, you will find y1 is equal to minus 3 plus 5 upon 2. So 5 minus 3 is 2. 2 upon 2 is 1. So we will be getting the coordinates of B as 4, 1 by midpoint. In the same manner, let coordinates of f as x2, y2. So we will be getting x2 is equal to, because f is the midpoint of AB. So 5 minus 1 upon 2. 5 minus 1 upon 2. So x2 is equal to 4 upon 2. So naturally x2 is equal to 4 upon 2 is 2. Now you will get y2 is equal to y2 is equal to. Now y2 is equal to 1 minus 3. 1 minus 3 upon 2. Obviously we will find 1 minus 3 is minus 2 upon 2. So y2 is equal to minus 1. Minus 2 upon 2 is minus 1. So I will get the coordinates of f as x2, y2. That is 2, minus 1. Fine. Now what is left out? E is the midpoint of AC. E is the midpoint of AC. So let coordinates of E. Let coordinates of E as x3, y3. Coordinates of E as x3, y3. Now x3 is equal to x3 is equal to 3 minus 1 upon 2. So x3 is equal to 3 minus 1 is 2. 2 upon 2 is 1. y3 is equal to y3 is equal to 5 plus 1 upon 2. 5 plus 1 upon 2. So y3 is equal to 6 upon 2. So that will give you value of x3 as 1, while that of value of y3 as 3. 6 upon 2 is 3. So 1 comma. Now this is how you will find out to get the value of AD by distance formula. We know the coordinates of A as well as B. To get the length of CF, we know the coordinates of C as well as F. To know the length of BE, we know the coordinates of B as well as C. So we know the coordinates of both the points. We can use distance formula and very easily we can find. So length of median AD is equal to, at once only we'll write the formula x1 minus x2 the whole square. Of course, this x1 minus x3 y3 has no connection with this x1 minus x2 y2. This is a general formula. Plus y1 minus y2 the whole square. Now let's substitute the values. AD, see here. So minus 1 minus 4. Minus 1 minus 4 the whole square. Plus 1 minus 1 is 1 minus 1. That will give you, of course, minus 5 square. It's 25. So AD is 5. Length of AD is 5 by distance formula. Very easily we got the length of AD. In the same manner, length of B is equal to median B is equal to median B is equal to median B is equal to 5 minus 1 the whole square. 5 minus 1 the whole square plus 5 minus 1 the whole square minus 3 minus 3. Be careful here. Minus 3 the whole square. Minus 3 the whole square. So BE is equal to 5 minus 1 is obviously is going to become 4. So 4 square minus 6 square. So that gives you 16 plus 36. That is root 52. 13 fours are 13 fours are. So that will give you 2 root 13. Trying to understand, because 52 we can split it as, of course we will find 13 fours are, so it is 2 root. Only one median is left out and that is nothing but CF. Okay, so median CF is equal. Median CF is equal to, we have already written formula at the beginning only, so simply solve it now. 3 minus 2 the whole square plus 3 minus 2 the whole square plus 5 minus of minus 1. Be careful here. 5 minus of minus 1 the whole square. Now what happens here? 3 minus 2 is 1. 5 plus 1. That gives you root 37. Median CF. Median CF, length of median CF is root 37. So this is how you will find this sum number 13 gets over here. Let's have a look once again to this one. Very important that they have not given us the coordinates of the midpoints. That is very, very important. They have simply given us the vertices ABC and they ask us to find out what medians. So first job we have done it is and to find out the midpoints. So 5 plus 3 is 8, 8 upon 2 is 4. 5 plus 3 is 8, 8 upon 2 is 4. Then minus 3 plus 5, 5 minus 3 is 2. x1, y1 I got it as 4 comma 1. Likewise you will find, then I got the coordinates of f as minus 1 plus 5. 5 minus 1 is 4. 4 upon 2 is 2. So here I have 2. Then in the same manner, minus 3 plus 1. Minus 3 plus 1 is minus 2 upon 2, that is minus 1. In this case, you will find 3 minus 1 is 2. 2 upon 2 is 1. While 5 minus 1 is 4. 4 upon, okay, 5 plus 1, sorry. 5 plus 1 is 6. 6 upon 2 is 3. Then AD is equal to x1 minus x2 the whole square minus 1 minus 4 the whole square, that is minus 5 square. Correct? Because 1 minus 1 is ultimately going to be a 0. That is root 25 square. Then let's find out the BE. BE is 5 minus 1 the whole square. That is 4 square here. Then minus 3, that will give you minus 6 square. 36 plus 16 is 52. And 52 is nothing but 13 fours. So 13 fours is root 30. Then to get the length of CF, 3 minus 2 the whole square plus 5 plus 1 the whole square. By 5 plus 1 minus of minus will give you plus. So 1 square plus 6 square, that will give you 37. So dear students, this is how the sum is over here. So I am going to conclude this lecture number 22 here. This definition of median, what is meant by median? If you don't know that the segment drawn from opposite vertex to the midpoint of base and all, then you will find it little bit difficult. Okay. So please have a look at this one. Once again, I am very much thankful to all of you for watching this video. Hope that you have got a very clear idea about these two sums. Thank you. God bless you all. I am going to conclude this lecture here. Thank you very much.